Hello. In this video presentation I'm going to be discussing and showing the method for solving simultaneous equations using the linear combination method. So we'll use this example here, and we'll take this one over here. This comes from your textbook. So we have 5x minus 6y is equal to 2 and minus 4x plus 2y is equal to minus 3. Now the idea behind this method is that we multiply 1 or maybe 2, both equations, by some constant value, some number. So either the x's or the y's can be cancelled by either adding or subtracting them. So when I have a look here, probably the easiest way I can do this is look at my y, because if I multiply this whole equation here, by 3, I see that my 2y is going to go to 6y, and then when I add them together, those y's are going to cancel. So that's what I'm going to do. I'm going to rewrite the top equation. I don't need to do anything there. Over 2, and then this is going to be minus 12x plus 6y is equal to minus 9. And now we see that we can just add the top equation to the bottom equation. I'm going to get there negative 7x. I'm going to add this whole equation to the top equation. I'm going to get negative 7x. These cancel out, so I actually get 0 here, that cancels out, and I get is equal to negative 7. So I'm going to get x is equal to negative 7 divided by negative 7 is equal to 1. Now I have the value for that. I can use any of these equations, this one, this one, this one, this one. I can use any of these, and I can substitute the 1 in to find the y. I'm going to just choose the simplest one, which I think is this one over here. I'm going to substitute my x into there and then solve for y. So it's going to be 5. Now remember, whenever you substitute, always put in a bracket, especially when it's a negative number that you're putting in. But just get into that habit. Is equal to 2. So there I've replaced my x by 1. And I'm going to get minus 6y is equal to 2 minus 5. Taking the 5 to the side becomes negative. So I'm going to get y is equal to minus 3 over minus 6, which is equal to minus 1/2. So my solution for this equation, for these simultaneous equations, is 1 for the x, and not minus, sorry, I don't know why I wrote minus there, because it's a negative divided by a negative, so that's a positive. That will equal positive 1/2 and 1/2. And that's using the linear combination method. Perhaps I can just do it the same problem, but just do it slightly different. You can see it works. So let's rewrite it again. But this time I'm going to do it slightly differently, and you'll see that it works out exactly the same. So if we have 5x minus 6y is equal to 2, and we have minus 4x plus 2y is equal to negative 3. What I could have done with this method, instead of getting rid of the y's, I could get rid of the x's by multiplying. So I'm actually going to multiply, you see this over here, I'm going to multiply the top equation through by 4 and the bottom equation through by 5, and then both your x coefficients will be a 20 value. So I'm going to multiply that whole equation like that and that whole equation like that. So that's going to be 20x minus 24y is equal to 8. And I'm going to get minus 20x plus 10y is equal to negative 15. So now you see I've got a negative and a positive, so if I add them together they'll cancel, so I'm going to just add them. If they were both the same sign, then I'd have to subtract. So I'm just going to add that to that. That cancels, these two cancel. Then I'm going to be left with negative 14y equals to negative 7, like that. Negative 14y is equal to negative 7. I'm going to say y is equal to negative 7 divided by negative 14, which is equal to 1/2, which I got before. Let me just perhaps continue over here so that I can put it in the space. I now take that half and I substitute into any one of these equations. I'll do the same as I did before. I put it into this equation. So I'm going to get 5x minus 6, and now remember, put this in brackets. That's a half equals 2. So I'm going to get 5x minus 3 equals 2. I'm going to get 5x is equal to 5, because that minus 3 goes over to the side, it becomes positive 3, adds together with a 2 to be 5, and I'm going to get x is 5 divided by 5, which is 1. So I have my same solution as before, but perhaps the other one was easier because I chose the easier route, the easier route to follow. But that is an example of using that method to solve simultaneous equations.